Good morning, everyone, and thanks for joining us today. I'd like to start by acknowledging that I am speaking to you from Vernon, which is on the unceded territory of the Silks Okanagan people, the original inhabitants of this land. You have joined part 3 of the 3-part webinar series on getting your project around water to shovel ready. My name is Marta Green, and I'm a senior hydrogeologist here at Associated. And like the last two, I'll be facilitating. An update on my backyard chickens. So I've got 3 egg layers out of 4. So I'm not sure how long I wait with the 4th, or if she's just going to be an auntie. All good stuff. So recap on our webinar series so far. The first part was with Heather Taylor, who's a senior aquatic biologist and BC regulatory specialist. Heather presented on the specific regulations and permits required for construction around water. And if you haven't checked it out, that session is now posted on our YouTube channel. So just go to YouTube and search for Associated Engineering. Then for part 2, Carrie Nadeau, a senior ecologist, talked about some treatments you can make instead of your typical riprap or concrete reservoirs for erosion control and stormwater management in your streams. A highlight for me was understanding that those techniques can make projects multi-purpose by adding more green space, habitat, or by allowing a little bit more natural attenuation of contaminants. In a way, they clean up our waters. And last but not least, today we'll be with Drew Lejbak, senior hydrologist. The first 2 sessions were more locally focused around a planned construction site. And for those of you that have a little bit more time and are working on long-term planning, let's say you are planning a water withdrawal or the province has asked you to do an environmental flow needs as part of your water license application, Drew will shed some light on the mystic world of EFNs. To help moderate the Q&A portion this week, we have Rob Hugendorn, a senior fisheries biologist with 20 years experience based out of our Vancouver office. Rob leads and manages fisheries and aquatic assessments in the Lower Mainland and throughout BC, including, of course, environmental flow needs of stream flow diversion and groundwater extraction projects. So for me, as a hydrogeologist in school, the focus was on rocks, geology, water, and never about fish. I avoided fish and anything organic. But now, with the Water Sustainability Act, Rob is definitely a popular commodity around the office. So similar to last time, we also have Melanie Puretsky, senior ecologist, in our Vernon office, and she'll be supporting Rob with that. So welcome, Rob, and welcome back, Mel. So without further ado, let me introduce Drew Lejbak. Drew is a senior hydrologist with 15 years of experience. Drew's area of specialty is surface water measurement and modeling, and in this role, Drew is a widely recognized expert in developing the natural flow curves of streams that go into building and setting an EFN. His other experience includes flood, debris flow and erosion assessments, mine drainage and settling pond assessments, channel hydraulic geometry investigations, peak and low flow analyses, regional hydrology assessments, water balance investigations, climate change assessments, and water supply and demand investigations. We are very lucky to have been able to take Drew out of his hip waders in the middle of a stream setting and into this virtual setting to share his knowledge with all of us. So welcome, Drew. Take it away.
All right, thanks, Marta. Hi, everybody. As Marta mentioned, my name is Drew Lejbak. I'm a hydrologist with Associated Environmental, and I'm located in our Kelowna office. And today I'm going to talk to you a little bit about environmental flow needs, or EFNs, and how they're considered as part of water licensing or water diversion projects in British Columbia. So a quick outline of my presentation today. I'm going to start out by defining what environmental flow needs are and why they're important, why we need to consider them. I'm also going to talk to you a little bit about the provincial EFN policy document that was released by the province to support water licensing decisions and water management decisions to try to help balance the needs of water licensees as well as the aquatic ecosystem. And then I'm going to touch a little bit on environmental flow needs setting approaches and how we would go about doing that. And then I'm going to wrap up with a quick summary. So overall, my presentation is going to be about 20 minutes today. So just to start out, I'm sure a lot of you have heard of the term environmental flow needs. So I thought I'd just kind of define that again and kind of start from the basics a little bit. Within the BC Water Sustainability Act, environmental flow needs have been defined and included, and they're defined as the volume and timing of stream flow required for proper functioning of the aquatic ecosystem. And really what this means that with the definition of environmental flow needs included within the Water Sustainability Act or the WSA, now any water management decision regarding licensing or diversions need to consider the aquatic ecosystem needs. So the aquatic ecosystem needs water at certain times of the year to ensure that the respective life histories of particular species are adequately met to ensure that the aquatic population is able to sustain and thrive into the future. Also included in the Water Sustainability Act is another term, the critical environmental flow threshold. And this is a term referred to or defined as the volume of stream flow below which significant or irreversible harm to the aquatic ecosystem is likely to occur. And really this is kind of the bottom end stream flow that we would see in a watercourse in which the aquatic population could survive. This is kind of the really low flow end of things. And if we drop below this, then we may be at risk of losing that aquatic resource. So with the inclusion of EFNs and critical flows within the WSA or the Water Sustainability Act, as I mentioned before, now water management decisions regarding surface water as well as groundwater licensing in BC needs to consider the aquatic ecosystem needs. As well, with the inclusion of critical low flows within the WSA, the province now has the ability to potentially restrict water withdrawals from a system if the system is defined to be at a critical point. So an individual or licensee may be asked to reduce their diversion, or potentially it could be eliminated at some point under very extreme conditions. EFNs are also considered by Fishery and Oceans Canada as part of Fishery Act authorizations and requirements surrounding those authorizations. And for projects like stream habitat restoration, compensation channel, things like that. So that there's also some considerations for EFNs in those. But again, today my focus is going to be largely on the water withdrawal component and the relationship between or balancing between water demands as well as the ecosystem needs. So to start out, when we talk about EFNs, generally we have two information sources that we're really interested in. First being the aquatic ecosystem in general and what type of fish species are present, because that can determine how at risk a particular watercourse might be if we're looking to remove water from it. The second piece of information of interest to us are the stream flows in general. Is there lots of water available, or is it a very low flow dominated system? Because that again can influence some of the decisions around water licensing and the balance between environmental needs as well as community needs. So when we talk about the aquatic ecosystem, and I mentioned, generally we're talking largely around fish, we want to understand what type of fish species are present. And once we identify that, we want to understand really what the life history or the life cycle of that fish species is. So there are lots of information sources out there about particular species of fish and their different life histories. They're referred to as fish periodicity tables. Some examples are included on this slide, so you can see the different stages that are outlined here, and also included in these tables are the timing of the respective life stage, and this is kind of the critical times to ensure that there's water available to the aquatic ecosystem, or at least the species, to ensure that spawning can happen or fish migration can happen. And again, the idea is we want to have water during these times to ensure that that population is able to sustain into the future. So that's the fish side. And then on the stream flow side of environmental flow needs, we generally talk around naturalized stream flows. So this is defined as stream flow that would occur in a stream in the absence of flow regulation. So kind of what a water course might look like naturally, and what the aquatic population may have historically been accustomed to in terms of available water. Now, for a lot of water courses in British Columbia and elsewhere in Canada, there is water management that's occurring, reservoir management or water diversions, water extractions, things like that. So that type of stream flow is what we refer to as residual stream flow, and it's the type of stream flow that are defined as the stream flow that remains after current water use or management. So kind of what we see in reality. Now, when we're looking to establish an EFN or need to understand the aquatic needs, and we're dealing with residual stream flows, we may have to calculate out what a naturalized stream flow would be utilizing that information source available. So we may have to add water back onto the system in terms of what might have been diverted off, or remove some of that regulation, because again, generally when we're speaking about environmental flows, we kind of looking at the naturalized component of stream flows. Also, there are some methods out there, EFN setting approaches out there that look at another type of stream flow referred to as the maximum license stream flow. And this is kind of our worst case scenario residual stream flow in a situation where every individual that has a water license is extracting their full allocated volume, and as a result, this would kind of be the worst case scenario that we could see in terms of residual flows on that respective water course. But again, generally, when we're talking EFNs, we're talking naturalized or natural stream flow. So overall, what is an EFN and what does it look like once it might be established? So I kind of added this slide to the presentation here to kind of describe that in the simplest form. This is a hydrograph here on kind of the center left of the slide, where we have stream discharge on the y-axis and time on the x-axis. And we have, for this particular water course, we have a naturalized flow. As you can see, it's the blue shading and the blue line. But then we have an EFN threshold that has been established for this water course, which is the black line. Now, as you can see, the black line varies, with time in terms of the respective threshold or the environmental flow requirement. And again, this relates to the respective fish species that are present within the aquatic system, and it reflects the different life stages that are required. So spawning or migration or even just channel maintenance. We kind of want to have flushes of water come through and potentially clean out spawning beds and things like that. So that's why you might see an EFN threshold that kind of varies with time and generally does. Also included on the hydrograph here is the critical environmental flow threshold, and that again is the low end of stream flow that would be available to the aquatic resources where their population could still survive. Now, on the right-hand side of the slides, I've included a couple photographs of what these approximate stream flows may look like in a representative stream. So as you can see, for the EFN threshold, at some point, there's adequate amounts of water in the system. You could imagine the fish species are happy here. They're maneuvering around or migrating around quite well, and spawning, everything can happen well here. However, when we get to the critical stages, you can see the flows have dropped quite significantly, and really have minimum amounts of water. And you could imagine that the aquatic ecosystem may be struggling to kind of maintain their needs under these levels. So with that in mind, we're looking to establish, the amount of water that the aquatic ecosystem needs. But now the challenges become when, we as a community or individuals need to look to withdraw water for, a variety of different purposes. So this is where water management decisions come into play in terms of trying to balance water withdrawals as well as environmental flow needs or ecosystem needs. So I've added a couple scenario examples on here to kind of provide a bit more, some examples of what some decisions may look like in some water courses within BC, and kind of broke it down to some of the simplest terms in terms of almost buckets of water here. So under scenario one, in the upper left-hand corner here, we have a situation or a stream where we have appears to have lots of naturalized flow. There has been an environmental flow need established, a threshold established, for a certain portion of the year or throughout the year, as you can see in the blue. And then there's an application or existing water demand on the system that is small. So a community or an individual is looking to, or is extracting or looking to extract some water. So as a result, there appears to be a surplus of water in this situation, and so a water management decision might be made to approve this situation, or at least for the time of the year that this is being applied. It looks like this may have limited impact, or a water license may have limited impact on the aquatic ecosystem. However, if we look into scenario two at the bottom there, is kind of more into more common scenarios that water allocation officers are facing, where situations or water courses where there's not a lot of naturalized flow available. This might be an interior stream where we generally have low flows throughout throughout the summer windows and into the fall. Of the water that is naturally available or was naturally available to the aquatic ecosystem, they do actually require the majority of it to ensure that they're able to sustain their population. But we also have a community or individual that also needs a lot of water in order to meet their community needs or their agricultural needs or whatever it might be. So this is where we enter some challenges with water management decisions, because generally we might be looking at a deficit if this water license was potentially approved. So this is where some decisions or discussions have to happen between water managers in terms of balancing the needs of communities as well as the environment, or looking at opportunities to have implementation of storage to supplement flows later in the year, collect water during the spring, release water later in the year to meet either environmental flow needs or water demands, or both. So EFNs and water withdrawals, I think, are maybe somewhat simple to understand when we talk about surface water withdrawals by water intakes or ditch diversions or things like that. But with the requirement within the Water Sustainability Act of groundwater now requiring a license in order to have a well to remove water out of an aquifer, EFNs and groundwater withdrawals are actually something that need to be considered together in some instances. Now, included within the WSA and the environmental flow needs policy, which I'm going to get into shortly here, groundwater withdrawals that are deemed to come from aquifers that are identified to be reasonably hydraulically connected to a stream would need to consider environmental flow needs or the aquatic needs of that respective water course. So what does aquifers reasonably hydraulically connected mean, or how is a well potentially influencing stream flow? A perfect example would be the diagram in the bottom right hand corner, where you have a well installed relatively close to a water course, and eventually over time with sustained pumping, you potentially drawing water directly out of that stream. So you can imagine, in this situation, you could be drawing the stream down as a result of your pumping, and that could potentially affect the respective EFN or the aquatic resource needs. Now, there are some technical guidance documents available to support you if you're looking to apply for a groundwater license, and in the general terms, in terms of identifying if your aquifer is deemed to be hydraulically connected. In the simplest terms, generally unconfined aquifers and some limestone aquifers are generally considered to be connected, whereas confined aquifers or maybe deep bedrock wells and things or aquifers are not. So, but again, you would need to complete. You may have to complete an assessment to determine that connection, if it exists or not. So that kind of provides an overview background of what environmental flow needs are, why we need to consider them, why they're important. Now, once the Water Sustainability Act was released, and the inclusion of environmental flow needs were identified, it was also identified that there needed to be an environmental flow needs policy or guidance document to support water management's decisions around the balance between water licensing as well as environmental flow needs. So back in 2016, the province released the environmental flow needs policy, and really it provides an outline document for a consistent approach for water allocation decisions. And this document is largely used by the provincial staff in terms of water authorizations and decision making, but it can also be used by individuals like yourself that might be applying for a water license or whatnot, to kind of give you an idea of potentially how risky your or the risk level that might be associated to your water license application in terms of how much water you require versus how much water the aquatic ecosystem require versus how much water is already allocated on a respective water course. Now, outlined within the environmental flow needs policy, they also identify the different types of water withdrawals that require you to consider EFNs, and these are identified as new surface water license applications or amendments to existing licenses. So if you have an existing license and you're applying for an increase in volume or change in the timing of the withdrawals, you likely will need to have some type of EFN consideration as part of that approvals process. Also, short-term use approvals require EFN considerations, and as I mentioned earlier, groundwater use licenses from aquifers that are deemed to be reasonably hydraulically connected to a watercourse also would require EFN considerations. Now, there are some exemptions that identified without needing to consider EFNs. These include new domestic water license applications, so generally very small amounts of water that are being applied for withdrawal. Change approvals don't necessarily need to consider EFNs, as well as aquifers that are deemed not to be hydrologically or hydraulically connected to a respective watercourse in regards to a groundwater license. So included with within the environmental flow needs policy, the province has put together a risk management framework to help guide decision making. As again, the idea of this policy was to help make a consistent decision approach to the approvals of or the setting of EFNs, but as well as the approvals of water licenses. So on the right-hand side of this slide here, this is the general schematic. It's imagine it's too small for everybody to review the words or see the words directly, but it's a general schematic to help kind of you walk your way through some of the decision making in regards to your particular project of interest. So when an application comes in, or if you're reviewing for yourself, the things that you want to look at or individuals would look at are the type of species that are present on a respective watercourse and how sensitive that species is. Also, is there fish present in a watercourse or not? Because some decision making may change dependent on the fish presence or absence. So that's a critical piece in determining trying to determine the impacts of a water license decision. Other information of interest for your particular watercourse or an application is how sensitive is your hydrology really? How sensitive are your stream flows? Are you what type of hydrologic regime are you looking at? Are you is it a very dry environment and low flows? So that can impact some of the decision making around water withdrawals. Also, the province has defined a stream size as a potential factor in terms of identifying risk to water license applications. Particularly, a threshold value has been established at streams with mean annual discharges of less than 10 cubic meters a second are determined to be are identified as small systems, and these small systems can be at higher risk of trying to balance the demands of water users as well as EFN. So that's there might be a little bit more of a focus on kind of a riskier situation under a smaller stream than a larger stream. And lastly, other types of things to consider as part of water decision making on a water course. You want to take a holistic approach to the watershed. You want to know what type of water withdrawals are already present on the system, as well as the amount of water that you might be looking to remove, as well as then what type of EFN requirements are needed. So you're not necessarily just focused solely on your particular project. You might be looking at existing users as well, and potentially how you would be impacting available water to everyone. Now, in the end, there's this risk management framework in place, and again, it's just kind of a screening tool to support some decision making. But in the end, you can end up, kind of looking at the level of risk associated to your particular project or a license application or whatnot. And you can look at 3 different levels, levels 1, 2, and 3 as a result of your project. Level 1, you might identify that no additional information is likely needed. It might be identified that there is a sufficient amount of water on the system. So and you have a good individuals have a good handle on the system. Whereas you get into level 2s and levels 3 risks, there just might be more information that's needed. It might be high risk species that's present. There might be low flows. There might be lots of water diversion already happening and management happening. So you may be required to produce or conduct additional assessments to support your application further. So So there's a policy in place to help kind of guide some decision making around the consideration of EFNs when it comes to water licensing decisions. And as a result, you may be asked to complete an EFN assessment in support of your application. And some of the reasons why this happens is obviously part of that risk management framework that I just outlined, but also because EFNs have not been established for every water course in BC. There's lots of different water courses out there, and some water courses do have thresholds that have been set already, but you may be asked to do that, for your respective water course. It's just not been done throughout, every single water course in BC. But that's okay. There are methods available to help you come up with a respective EFN value for your water course of interest. There's different ways of doing that. There's desktop methods and field-based methods, and that some of the decision making around which method to use is going to be based off the amount of information you have available, to you. Do you have a really good handle on the type of fish species that are present, and are they at risk or not? And do you have lots of good hydrology information or streamflow information as well to kind of help guide some of your calculations or decisions around the setting of an EFN. So there are desktop methods. So if you do have lots of information available and under some circumstances where maybe it's deemed to be a lower risk situation, you may apply a desktop method. Within the environmental flow needs policy document, they do identify or provide recommendations for some approaches, which I've included here, the BC modified tenant method and the BC in-stream flow threshold method. So these are approaches that you can use. There are individuals out there that can help you apply these methods, that know these methods quite well. Fish biologists and hydrologists, individuals like that, have kind of conduct or use these methods quite regularly, and they would also be able to guide some of the decision making around different methods or the application of the methods based off of the hydrologic regime that you might be experiencing within your system, or the fish species and things like that. Now, not all the methods that are available may work for your system. As an example, within the Okanagan, there was a EFN project that was conducted, for the last few years here, and as a result, there was specific EFN setting methods that were developed to kind of focus in on the specific hydrology or the hydrologic regime that the Okanagan experiences. So just as an example of a method that was developed is the Okanagan tenant method. But again, there's individuals that are able to support you in the application of these methods. Now, when we talk about field-based methods, this is where we may not have a lot of information available to us on a respective water course. So we might have to go out and collect fish information, collect hydrology information, get in the channel and actually do some flow measurements, depth and velocity measurements, because we really want to establish, the habitat suitability for the respective fish species that are there. Also, field-based methods might be required because it's a bit more of a sensitive system, or is deemed to be a bit more high risk because there's multiple demands or conflicting demands for available water. So that's why we want to get out to the field and conduct the necessary measurements to ensure that we're, an EFN value that we're proposing or recommending is really applicable to that system of interest. So overall, in the end, whatever EFN method that you choose to use, it's generally a step-by-step process. It's not something that you're kind of having to generally make up. There's guideline documents to help you kind of step through that process. And just as an example, I included on this slide the Okanagan EFN setting method. So this is the desktop method for producing EFN thresholds within the Okanagan. And it's a 20-step process. I know you can't read the specifics in each of the step, but at least it's more of the idea is that there is a guideline here to help you consider the necessary components of fish species and hydrology, stream flows, things like that, and kind of walk your way through. So there are methods out there, and again, there are individuals that are out there to help you kind of do that if you are identified or the province identifies you to complete an EFN assessment. So just to quickly wrap up, environmental flow needs, in the end, when we talk about that, we're really talking about, the aquatic ecosystem needs, and, in simplest terms, they're, threshold values that we're looking to be set on a respective water course to ensure that any water withdrawals that we're considering that are considered on a respective water course are actually considering the ecosystem needs. Because the idea is we want to try to balance the needs as best as possible between the existing users, new users, as well as the aquatic environment to ensure that we're able to sustain the aquatic environment in the future, but as well as meet all our community needs, particularly with the changing climate that we're currently in. I just wanted to throw out a couple of acknowledgements for the presentation today. The Okanagan Basin Water Boards and the Okanagan Nation Alliance. These were two groups that I've worked with as part of the Okanagan EFN project, and I did borrow several images from them for this presentation, so just wanted to thank them for that, as well as acknowledging the BC Ministry of Forest, Lands, Natural Resource Operations and Rural Development, and some discussions I have had circling around the EFN policy and how that's considered as part of water allocation decisions. Thank you.
Thanks, Drew. And every time I hear a presentation on EFNs, I learn a couple more new nuggets, and I'm building on my own data set and starting to apply it little by little in my own practice. So thanks for that. And Rob and I have been busy gathering your questions. So thanks, everyone. We've got some really good questions to discuss. Rob, which one were you thinking of starting with?
Yeah, good point to try and figure out where to start here. Thanks so much for the questions, and yeah, like Marta said, some really good ones. I guess the one I was thinking about starting with is the one on climate change. There's a good question about obviously those, we have some environmental flow needs that are established for certain systems, and they're based on hydrometric records. And current water licenses have been established based on that. How is climate change affecting those water licenses and establishment of new EFNs?
That's a good question. I still think with EFN being a bit of an emerging science, we're still, considering, how to consider climate change in some form. There's lots of information out there in terms of understanding, the changing hydrology that is potentially happening in different water courses or going to happen in different water courses across the province. So, we're looking at, potentially being flexible, I think, in terms of, some EFN, threshold establishments to consider the, maybe the changing hydrographs that might be happening, as well as kind of maybe putting some conditions within licensing as well to kind of identify that water might not be available under some years based off of future situations.
Had a water quality question in here related to the use of groundwater for a hatchery and putting that groundwater back into a stream during low flows established under an EFN. And just wondering what the potential chemistry interactions might be of that low flow and how that would affect an EFN as well as the stream productivity. Marta, did you want to take a stab at
Sure,
addressing
yeah,
groundwater?
something I can contribute to. Yeah, so groundwater quality will definitely need to be considered if you want to use it to supplement flow. It can work. It's going to be cool because the average groundwater temperature happens to be around your average annual air temperature. So it's nice and cool. Fish like that. But as far as the water chemistry, yeah, you definitely want to take samples. Sometimes it's great water quality, but sometimes you have iron and manganese, which will deposit once it hits atmosphere. So you'll definitely want to consider that. You will have to do either a license amendment to your surface water license or a new groundwater use license application, and that'll probably require a technical assessment in support of that application, but every situation is different. So hopefully that helps you a little bit.
Thanks, Marta. Yeah, there was another really great question about the frequency of establishing an EFN and following up on that. So the question is, once an EFN threshold has been established, how often should it be reviewed? Yeah.
Yeah, that's a good question. I think that's like there's the EFN policy that is out there right now. Provides some guidance in terms of considerations, and the EFN policy is not necessarily a set in stone document. There may be releases or updates to that policy in terms of considerations. So I think the province will consider once an EFN is recommended, with additional applications and things like that, there may be, you may change it, or with additional information, there may be some refinements to that EFN with time as we gain more information, or we gain a better understanding of a respective watercourse or the demands on that watercourse.
Yeah, you've mentioned the variety of different information sources that go into establishing an EFN. So there can be, as new information is collected, whether that's aquatic use of a system, or if it's hydrometric information, yeah, that could be continually evaluated. I think that, yeah, so if the data is limiting, it's good to take another look at things as data becomes more available, or if species use changes. We had a couple other questions that came in specifically during the registration period, and I thought I'd go to those two to see if I can cover them off. And I apologize if I'm not getting all of the questions. I think that there's a process afterwards to respond and provide answers to all of the questions as follow-up. So I think Marta will be clarifying that. But yeah, one of the questions was, I think you touched on this during the presentation, but do you always need an EFN for every water license application? Maybe you could just clarify that.
Sure. Yeah. So as I kind of outlined in the presentation on one of the slides, identified that new surface water license applications or amendments to existing surface applications would need to consider EFNs in some form. Short-term use approvals also require EFN consideration, as well as new groundwater use licenses where the aquifer is that you're looking to draw water from is deemed to be hydraulically connected in some form to a nearby watercourse. So those would be the things to consider, or new considerations for EFNs in terms of on the exemption side. New domestic water licenses generally may not require a EFN consideration. Change approvals wouldn't, as well as aquifers or groundwater licenses where you're looking to draw water from a aquifer deemed not to be hydraulically connected.
Another great question that came in was in regards to the risk management framework. So it says, does species sensitivity in the risk management framework only consider fish species, or also other aquatic species such as insects?
Yeah, sorry, go ahead.
Oh, go ahead.
Well, my understanding is that it's really like a holistic approach of the aquatic environment. So that would be the the fish species that are there, but as well as other benthic invertebrates or things like that that might be present, or because they're obviously, we need to have both of those functioning together to ensure that the aquatic ecosystem is sustainable into the future for all aspects of it. So there would be a consideration. I think from some of the screening approaches, they may look at just simply some of the fish species at first, but would also consider like the other aspects as well.
Yeah, just to add to that a little bit, yeah, there is consideration of essentially fish species as a first point of looking at the risks. And you know, obviously that it cascades from there, whether that's water allocation questions and cumulative withdrawals and whatnot, to really look at additional risk. But as a first point, you look at fish species. If there is no fish species present, then yeah, there is further consideration under the Water Sustainability Act, but also under the Fisheries Act. It's still considered, there's still fish habitat contribution there. So there is thresholds set to establish just a small amount of flow in non-fish bearing systems. So benthic invertebrates is a component in looking at those lower flows for non-fish bearing systems as well. So just to add to that, Drew.
Thanks, Rob.
I guess a question that's been asked in other webinar series that we've had here in the first two was a question in relation to education opportunities or research around this topic area. And so I thought I'd throw that out there as well. Do you see any additional areas of research or educational opportunities in this particular area?
Oh, for sure. As I think I mentioned earlier, EFNs is still, you know, the establishment of EFNs and approaches is still a bit of an emerging science. So I still think there's lots of research opportunities out there to investigate, you know, changing streamflow patterns related to climate change and things like that, and the potential influence that might have on aquatic populations, and still research on, you know, fish species and their needs as well. So I think there's lots of opportunities there. In terms of education, you know, I know there's lots of interest in EFNs. Back in, I think it was October or November 2019, the Okanagan Basin Water Board in the Okanagan organized an EFN conference, and it was you know, attended by, you know, lots of individuals that were really keen on kind of learning and understanding EFNs. So I know there's a real big interest in it on an educational standpoint as well. I think there's a community opportunity as well in terms of community-based monitoring for, you know, hydrometric monitoring and things like that, to provide you know, information regarding streamflow, you know, streamflows on lots of, you know, different water courses that might be deemed you know, critical for, you know, respective aquatic resources, you know, through linear parks and things like that as well. So yeah, I think there's lots of opportunities out there to kind of, you know, build upon, you know, the existing knowledge base and kind of grow from there.
Yeah, I agree. Just to add to that, certainly in the habitat species framework, there's, you know, EFNs are established, and sometimes there's very sensitive species that little information is known about the interactions between flow and their habitat requirements. So there's lots of research opportunities as well. And you mentioned the community opportunities to continue to monitor those habitats, and that's certainly an area where there's lots of additional opportunity to continue to grow the knowledge base. And
Rob, there's one coming in from, there's another question that's come in here by Jenny, which would be a good one for Drew to review, the naturalized and residual net streamflow. Do you want me to ask it?
Yeah, go ahead.
Another one just came in. What happens if the existing flows are below EFN? Will a license be denied, or a municipality required to reduce its existing use?
No, I think that's, well, if it's a new application, then there may be, you know, consideration on that license for, you know, approvals with potentially, you know, storage to ensure that the water demand, you know, or water could be collected during the spring when there's adequate water available to rebuilders at certain times of the year. So I think, you know, we're going to get into, you know, there will be some water management decisions that are going to occur throughout the year, potentially, to ensure that, you know, it's a balance in some form in some situations to meet the needs of the community as well as the aquatic ecosystem.
I'm pretty sure I know the area she's talking about, and it's an existing water license.
And I guess the EFN serves as your tool to help those municipalities make those decisions, right? And working together to look at that science to help make decisions, because if it's related to, say, agricultural producers, to not allow them to use water would cripple their operation. But the EFN is a tool to help make those decisions. So I would imagine it'd be site specific.
Mm-hmm. For example, like the Coldwater River and the Coxsila watershed. The whole point of the water sustainability is to help manage water use conflicts in times of water scarcity. So yeah, definitely. The EFN is just one of the tools that we need that goes into that decision-making process.
Yeah, and the province may request or may identify, some reductions in diversions at certain times if you're approaching the critical low flow on a system, or under provincial drought levels have been identified. Then that would kind of come into the decision process as well, in terms of water diversions and things like that.
And if it's going to make a difference, right? You have those great hydrographs of situations for a certain, I think it was interior streams, where you showed if adding, like stopping the water licenses from using their water, if that addition would help the habitat, if it would actually make it above the critical flow or the EFN.
Yeah.
There's another question here related to tidal outflow, and just thought I'd address that here.
2 minutes.
Okay, well, quickly then. What impacts are analyzed from wastewater outflow on a tidal riverbed, and how would that affect chemical impact? So I'll just address that, I guess, and basically saying that I think that particular issue is probably more, while it would relate to the minimum flows in the creek, I think that dealing with the chemical issues of a wastewater outflow would be covered under a different process. Probably we're looking at the receiving environment in a wastewater discharge permit situation. So you'd be looking at, how much dilution there is at low flow, rather than establishing what that low flow is. So hopefully that addresses your concern and your question there. I think that's, I guess, given the time, that might be all I have, unless you guys had something else there that we could address quickly.
Trying to flip through if there's any that are 1 minute or less, because you can definitely open up any of these topics and have our own webinar on those topics. So no, I think that was great. So yeah, that wraps up the Q&A portion, and that also wraps up our webinar series, Getting to Shovel Ready. I hope these were helpful for you and your organization to hopefully expand your knowledge on these rapidly changing areas of practice, maybe bring up just as many questions as answers. While we're on the theme of change, a reminder, these presentations are a summary on the regulatory and technical highlights in this moment in time. And since the WSA was established in 2016, we expect this rapid change to continue as we all become more familiar with the WSA, us as practitioners and the regulators themselves, as more technical studies get developed, and as the databases that we're all familiar with get updated. So from my side, I'd like to thank all of you for joining me for this entire series. It's been great. I obviously, with COVID, have been feeling a little bit disconnected from the water community. So by putting on these webinars, it's been really making me feel connected again to the community. So thank you. As a reminder, if you happen to have missed a part of this webinar, or you missed one of the other 2 previous ones, we will be posting the sessions on our, there it is, our Associate Engineering YouTube channel. And I believe the second one is either posted now or will be posted by the end of the day. Let's see, if you have any other specific questions, just please feel free to email me or Drew, and we'll find someone to answer it for you. Once again, we'll be sending out a short feedback survey. Since this is the last session, please take a moment to let us know not only what you think about our subject matter experts and our topics, but also any topics you might be keen to hear about in the future. And a reminder, these sessions do qualify for 2 hours under the informal category for your continuing professional development hours with EGBC or similar. And in closing, thanks to Drew, Rob H, and Melanie for making this last webinar a success, and stay safe and have a great summer. Bye.
Thank you. Bye-bye.
Thanks.